Hi everyone, in this video we are going to see how to find the equation of the chord of contact for a pair of tangents drawn from a given external point to a given circle. Let's suppose we have a circle like this whose equation is x squared plus y squared plus 2gx plus 2fy plus c equals 0, having center at the point C whose coordinates are negative g, negative f. And let's suppose we have an external point P whose coordinates are x sub 1, y sub 1. Next, I am going to draw the two tangents from this point onto the circle. Here is the first tangent. Let's suppose the point of contact is A, and let's assume that the coordinates of that point are x sub 2, y sub 2. Next, I am going to draw the second tangent. Let's suppose this is the second tangent, and let's suppose the point of contact for this tangent is B, and let's suppose B's coordinates are x sub 3, y sub 3. And the yellow dotted line that you see, that is actually the chord of contact. That is called the chord of contact. It's the chord joining the 2 points of contact for the pair of tangents. So AB would be the chord of contact in this case, and we have to somehow find the equation of this line AB. Now, what would be the equation of the tangent line going through the point A? Well, it would be like this. We have seen that in a previous video. The equation of the tangent line going through the point A whose coordinates are x sub 2, y sub 2, that equation would be x times x sub 2 plus y times y sub 2 plus g times x plus x sub 2 plus f times y plus y sub 2 plus c equals 0. In this case, g, f and c, they come from the given equation of the circle. And similarly, what would be the equation of the tangent going through the point B? Well, that would be kind of like this. It would be x times x sub 3 plus y times y sub 3 plus g times x plus x sub 3 plus f times y plus y sub 3 plus c equals 0. And now if you think about the two tangent lines, you see that both of them actually go through the point P. And P's coordinates are given as x sub 1, y sub 1. That means P's coordinates also should satisfy each of these equations of the tangent lines. So if we use P's coordinates on the first equation, then the equation going to look like this. All I have done is, in place of x, I am using x sub 1, and in place of y, I am using y sub 1. And next, I am going to do the same thing for the other equation, for the second equation. Because that second tangent line also passes through the point P, P's coordinates should satisfy that equation as well. So here again, I have used x sub 1 in place of x and y sub 1 in place of y. Now, let's have a look at these two new equations for a second. Each of these equations would be a linear equation. And looks like both of the equations are kind of identical equations. It's just that the first equation has been satisfied with the coordinates of the point A, and the second equation has been satisfied with the coordinates of point B. So now if I try to write a general form of this equation that would satisfy the coordinates of A and B, I mean in place of x sub 2 and x sub 3 I am going to use x, and in place of y sub 2 and y sub 3 I am going to use y, then the general form of an equation could be like this. So from the two equations in white color, I have been able to derive a general form of the equation that could look like this, and that would satisfy the coordinates of the points A and B. Think about it. In place of x, if you use x sub 2, and in place of y, you use y sub 2, then you get the first white equation. And in place of x, if you use x sub 3, and in place of y, if you use y sub 3, you get the second white equation. That means from the two equations in white, I am able to come up with a general equation which is again a linear equation, and that would satisfy the coordinates of the 2 points A and B. Also, we know that we can draw only one line through two given points. That means through the points A and B, we can draw only one line. That means this equation that we are seeing in green color here, that must be the equation of the line going through the points A and B, which is nothing but the chord of contact in this case. So essentially, we have been able to come up with the equation of the chord of contact. And if we rewrite the equation, it is going to look like this. So that is the equation of the chord of contact which is passing through the points A and B. I hope things are clear up to this point. Next, I am going to take a couple of cases. When the point P lies outside of the circle, then this equation actually represents the chord of contact. Now let's take a look at the second case. When P actually lies on the circle, then this equation would actually represent the equation of the tangent line at that point P. So it's very interesting to note that the equation of a tangent line could also represent the equation of the chord of contact. And I'll show you a visual representation of that, and there you will see how the chord of contact could coincide with the tangent at that point. So let's have a look at the next diagram here. Let's suppose we have a circle like this, and here I took a point P and I drew two tangents from that point onto the circle, and I have the chord of contact denoted by the yellow line there. Now I'm going to move the point P towards the circle. Let's suppose now the P is right here, and in that case how would the tangents look like? Well, I have the new tangent lines and also I have the new chord of contact which is in pink color. Next I'm going to move the point P even closer to the circle. Let's suppose the point P is now like this, and here again I have the new chord of contact in red color. So now you see, as the point P is approaching the circle, the chord of contact also becoming smaller and smaller, and it is actually approaching a point on the circle where P is going to land eventually. So finally, let's see what happens when P approaches the circle and lands on the circle. I mean, P happens to become a point on the circle. In that case, the two tangents will actually become one tangent, and also the chord of contact will become smaller and smaller and smaller and smaller and smaller and become just a point, and that will lie on the tangent. So that means the chord of contact's equation will also be same as the equation of the tangent line. That's just a limiting case. I tried to represent that idea through this diagram. I hope it is making sense, that as the point P approaches the circle, you will notice that the chord of contact is going to eventually coincide with the tangent at the point P on the circle. So from here you can make a good guess that yes, the equation of the chord of contact actually similar to the equation of the tangent drawn at the point P on the circle. I hope everything made sense. Next we are going to take an example. Let's suppose we have an example like this that says find the equation of the chord of contact for the tangents drawn from an external point P whose coordinates are given as 2, 3 onto the circle whose equation is x squared plus y squared plus 6x plus 4y plus 8 equals 0. So let's get started with the solution. First, let's compare the given equation with the general equation of a circle. The general equation looks like that: x squared plus y squared plus 2gx plus 2fy plus c equals 0. And from here, what would be the value of g? Well, the value of g would clearly be 3, positive 3. And what would be the value of f? Well, that will be positive 2. And what is the value of c? That's given as positive 8. And what is x sub 1? Well, that's the x coordinate of the given point P. And what is y sub 1? That's the y coordinate of the given point P. So x sub 1 and y sub 1, they would look like this. Now let's try to come up with the equation of the chord of contact. Well, just now we have derived the general form of the equation, and that equation kind of looks like this: x sub 1 times x plus y sub 1 times y plus g times x sub 1 plus x plus f times y sub 1 plus y plus c equals 0. Now let's plug in the values here. I mean the values of x sub 1, y sub 1, g, f and c. Once we plug in the values, the equation going to look like this. All I have done is I have plugged in the values of x sub 1, y sub 1, g, f and c. And if we simplify the equation, it's going to look like this. And let's simplify a little more. The equation will look like this. And if we divide both sides by a 5, because 5 is a common factor here, so if we divide both sides by a 5, then we are going to be left with an equation which will look like this, and that is the answer. So this is the equation of the chord of contact for the pair of tangents drawn from the given point P onto the given circle. I hope everything made sense. Thank you for watching. See you in the next video.